Okay, students, good evening and welcome for this important lecture. As I discussed in the first lecture, we were talking about titrations and what titration we have done in the last lecture. Which titration was done in the last lecture? Tell me which titration we have done, students, in the last lecture. You are doing titrations and you have done strong acid. What we did? Strong acid strong base titration. Okay, this we have done. Tell me, did we do this?
Yes.
What we did here. Here I said you
Yes,
can see
sir.
what we have done. I will just give a small revision. What we are trying. That in this beaker, what we have taken 25 milliliter of what I took in the beaker. A strong acid. HCl is a strong acid. You know how much you have taken? 25 milliliter of 0.1 mole decimeter cube of HCl. ठीक है? And in the burette, what did we have, students? NaOH. What was that? 0.1 mole decimeter in moles. ठीक है? This is the concentration of strong acid and strong base. And I have a pH meter. What the pH meter will do? What the pH meter will do, students? pH meter will give me the reading, okay, of the
Yes.
pH. So what I said, HCl is a strong acid. It gets ionized to form H plus and Cl minus. Okay? So what we did, we said
Yeah.
that we can plot a graph between the pH. What graph we are making, students? pH is, we are taking, this is our pH. What is this axis? I have two coordinate axes. I have two coordinate axes, student. In one axis, I am taking the pH. In this, you can see the pH here. It is going from 0 to
Yes.
14. So I am plotting pH is going from 0 to 14. As you can see, my y-axis. And I am plotting on the x-axis. This is my x-axis. What I am plotting here? X-axis. What is my this? Y-axis. Here I am plotting the volume of 0.1 molar NaOH added. What is this? Volume of NaOH added. So, and then I will keep on noting the pH from the pH meter. I will note the pH from the pH meter. Okay? You will get what you are getting. What we are recording. You are saying, sir, what you are having, that volume of 0.1 molar NaOH added versus pH. Okay? This is what we are doing. And as you can see, when I add, if there is a 0 milliliter of NaOH, the pH, how we will calculate the pH? You have a 0.1. Okay? The pH, how do you calculate the pH? pH is equal to minus log to the base 10 H plus aqueous. Okay? This is the formula.
Yes.
And if it is 0.1, then what will be the minus log of this? If I take the minus log of this, what is the pH coming? pH is equal to 1. Okay? So you are starting with pH equal to 1. Strong acid has a lesser the pH, stronger the acid. Clear?
Yes.
Okay. Supposing I added 10 milliliter of NaOH in this. What is the result of that? you are saying ki sir reaction is like this. OH minus will react with H plus aqueous. And what you are getting? H2O. So the concentration of H plus will decrease. It will decrease.
Yes, sir.
And if it decreases, the pH will increase. But you can see the first 10 milliliter, if I add, the pH change is only very small. It is from 1 to, if you make a calculation, it comes to around 1.37. Why? Because pH is minus log of H plus. Minus, when I take the log, the value becomes very less. So what has happened when you added 10 milliliter, the pH changes to 1.37. There is a slow increase. This is a very small increase. This increase is large or small? Small increase. If I add 24 milliliter, we showed you the calculations in the last lecture. How do we calculate? The pH goes to 2.69. Here in this graph what I am showing, you see this is a volume of the NaOH added. This is my 10 milliliter. Let me change the color if you want. You pay attention to the students. What happens? That this is the point. 10 milliliter. See the 10 milliliter? Then 20 milliliter. pH is this. And 24 is
Okay.
24 is just before that. 24 is, we are seeing it is slightly less than 3, this point. 24. After 24, if I add 25 milliliter, what will happen? You can see the pH immediately rising. Can you see this? This is the pH.
Yes, sir.
Up to 24, very slow, but as soon as 25, pH rises. Why? Because if you have taken 25 milliliter of 0.1 molar HCl. Now you add 25 milliliter of 0.1 molar NaOH. So you have equal moles of H plus and equal moles of OH minus. Okay? So this is a complete neutralization.
Yes.
Complete neutralization takes place. The result is, if I write like this, HCl plus NaOH, what is the product? Tell me. NaCl plus H2O. Okay? Now, equal moles are there. They are completely neutralized. Complete neutralization. H plus and OH minus completely reacts. You can see that NaCl aqueous. This is a salt. Tell me, is it a salt? But it is a neutral salt. This salt is neutral. Neutral means neither acidic nor basic. Water. What is water? Neutral. So when you add 25 and 25 students, the pH will immediately go to 7. pH is 7. Yes or no? Tell me. Neutral. For a neutral, what is the pH? You can see. Here I have shown this is called the equivalence. What do you call this? Equivalence point. Correct? Tell me.
Yes, sir.
This means the reaction is complete. Because equal moles of NaOH and HCl have been added, and you see this line immediately shooting. Reaction is complete. There is no H plus now in the solution. Is there any H plus left? No. And they are neutral. So they are neither acidic nor basic. So pH goes to 7. Now this means 7 here. Now I add another milliliter. What will happen? H plus is not there, but OH minus now becoming more, excess. And OH minus, NaH is a strong base. NaH is a strong base. So if I will calculate the pH of this student, this comes to around 11.29.
Yeah.
Between 25 and 26, you can see that how it shoots up. It is shooting up. Okay? The 7 is my equivalence point, which is a middle of this, middle of this. You can see middle of this. And the pH is like this. And if I further add more, what will happen? If you add supposing 5 milliliter or 4 milliliter more, 30 milliliter, then we find the pH is around 12.50. And you can add up to 50 milliliter. The pH continues to be 12.50 because that is the pH of the strong base. And 12.5 is the pH of a strong NaOH base. So after that, there is no change in pH because that is why you see the curve like this. Okay? So this is a titration curve of strong acid and strong base. Any doubt here?
No, sir.
Slow increase, at the equivalence point when equal volumes are added, you can see the region in which there is a change going from immediately changing values going from immediately 7 to 11 point something. So that means there is something called the end point. What is the end point? Tell me of any reaction. How will I know the reaction is complete? How will I know the reaction is complete? Something called end point. How do I know this is the end point? Tell me. I will have to add an indicator. I will have to add an indicator which will change its color where this region where the pH is changing maximum. So here the indicator which we should have is someone, because this pH is changing from 7 to what the pH changes from 7 to, the pH is changing from 7 to, you can say immediately it changed from, how much was it in the beginning? It was something before 25, 3. So from 3 to, it is going from 3 to 11, something like that. So it's a range 3 to 11. So we should have an indicator which will change its color during this period. During this period. What I can say, best indicator will be those which change their color from supposing 3.5 pH to 10.5 pH. Okay? If in this range some indicator changes its color, I can use it for this titration. Yes or no? Tell me. I can use it? Okay. Now let me go further. This is, I have shown a diagram here as a equivalence point. The number of moles of acid and base have been added are equal. The pH at the equivalence point for strong acid and strong base is 7. We are saying this is 6. This is our 7. 7. This is 7 pH. This point 7 pH 7. So these are some of the indicators which are changing their color during this period. Where when you have added 25 milliliter, you add another drop, then you see how much pH is changing. This is a range. This is a range for the indicator which I have shown. Which indicators are good for this? Then tell me how many indicators I have mentioned here. 1, 2, 3. So in the titration, you can use any of phenolphthalein can also be used here because phenolphthalein is colorless. It will become pink immediately as soon as you have the pH goes above 7. Below that, phenolphthalein is colorless, and as soon as it becomes alkaline, it will change its color. Phenolphthalein changes its color, student, from colorless to pink. Colorless to pink. In the region, this region I have shown. This is the region of the phenolphthalein. There are more indicators also. We will get a list of that, which is given in your book. Clear? Therefore, I can find the end point. Now, end point is come. What is the meaning of the titration? Supposing I had M1, or you are, what is the molarity of HCl here? HCl you are saying. How much was HCl? 0.1 mole decimeter cube. How many milliliter you have taken? V1. 25 milliliter. Okay? Now you don't know what is the molarity of NaOH and volume of the NaOH used. If I calculate from pH meter, from the end point, I will be able to know how much volume of NaOH has been used. Can I find it or not? It can be less than this or it can be more than this, depending on the molarity of the NaOH. This is for NaOH. Okay? This I don't know. So volume I will calculate from this burette. I will be able to do it, yes or no, tell me. So volume, supposing the volume is coming, in this case, if it is 0.1, it is coming 25 milliliter. So what is the result? M1 V1 is equal to M2 V2. So what is M2 then? M1 V1 by M1 V1 by V2. So what we have got then? We can find the molarity of the M2 unknown NaOH. Okay?
Yes, sir.
I will use an indicator, which is my phenolphthalein here. Okay? Phenolphthalein colorless to pink. As soon as the color changes to pink, I stop the reaction, measure the volume from the burette and do this calculation. Then I can find the molarity of the unknown sodium. This is why you are doing titration. That is what you told me last time. If I do the reverse reaction, reverse, what is the meaning of reverse? Tell me. I take in this beaker, what I take in this beaker? I am taking in this beaker, students, NaOH, 25 milliliter and 0.1 mole decimeter moles. What will be the pH of this? NaOH will give what? NaOH will give me OH minus ions. Okay? I can find the pOH from this 0.1 value. What will be the pOH of this? The pH of 0.1 will be what? If I take the minus log of this, how much it is coming? 1. Then what is pH? Plus pOH, tell me what is this? 14. Then what is the pH? 14 minus 1. How much? 13. Right or wrong? Tell me.
Right, sir.
So here you can see we are starting from this point. This is my NaOH. Then I start adding HCl 10 milliliter. Until the 24 milliliter, there will be small change. You can see the small change. Because what is happening? What is the reaction? You have OH minus, H plus you are adding, it is reacting. You have HCl. HCl is what? 0.1 mole decimeter cube. This you are adding from the burette. You are adding from the
Yes, sir.
burette. This burette contains what? HCl. So you are adding in this and you have a pH meter to record the pH. So this reaction is taking place. Same reaction. Only when you add 25, immediately you see large change, large change. See from this to this point. And again, at equivalence point, what will be the pH in this case? 7?
Yes, sir.
Because it is the neutral. And any indicator which changes its color during this range can be used. This is just a reverse of the titration which we did. These are the examples of strong acid, strong base titration. Any doubt?
No, sir.
Carl, you know how did we get this? On one axis, we plot pH. On the second axis, we plot the volume of HCl added. We have a pH meter to record. So we will get some points, 10 milliliter, 15, 24, 25 milliliter. Then further 20, just one change makes such a big change, then like this. And then finally, after 26 milliliter, you see the becomes constant, because then H plus becomes in excess. HCl is a strong acid. This is a titration curve. pH versus volume of the HCl added. This is called the titration curve. It helps me in choosing the right indicator. But it helps me, I can choose the right indicator. Okay?
Yes, sir.
Okay. Here I am talking of now a titration where I am using a weak acid. Can you give me example of a weak acid, students? What is a weak acid? What give me example.
Weak acid would be NCOH.
Or organic acids are weak acid. Here we are using CH3COOH. This is a weak acid. What do you call it? It's ethanoic acid. I'm
Yes, sir.
taking ethanoic acid 0.1 mole decimeter inverse, and I am taking 25 milliliter of this, which is 25 centimeter cube, is equal to 25 milliliter in my beaker. And in the burette I am taking NaOH is a strong base, which is 0.1 mole decimeter. ठीक है? Okay. Now what will
Yes.
happen?
Yeah.
It is a weak acid. The pH will be more or less than HCl. Tell me, weak acid. What will be the pH? Will be more or less, because it is a weak acid. HCl was a stronger acid. Its pH will be more or less than HCl. Tell me. If I take 0.1 of this, I can find the pH. How will you find the pH? The Ka value is given. Ka for ethanoic acid is how much? 1.74 into 10 minus 5. What is then? How you find the pH? You have done the questions on this. CH3COO minus H plus aqueous. What is the formula? Because Ka value is given. Ka value is given. Then what you use? Ka is equal to CH3COO minus H plus aqueous divided by CH3COOH. The concentration is known, and if I know this value, Ka is known. Ka is known. How much? 1.74, 10 minus 5. What is this value? How much acetic acid you are taking? 0.1. How much? 0.1. ठीक है? This value is 0.1 molar given.
Yes, sir.
So these two are equal. These two are equal. So square, and then I can find the value of H plus. What will be H plus square? What will be H plus square? This is 0.1 into Ka, which is 0.1 into 1.74 into 10 minus 5. Then what will be H plus aqueous? Tell me. Square root of this value. This is 1.74, 10 minus 6 square root. This will give me the H plus concentration. 10 minus 3, 1.74, square root of 1.74 into 10 minus 3. Then I will take the pH will be minus log of base 10 to the H plus. ठीक है?
Yes, sir.
If you will do this calculation with the calculator, this is coming, the pH is coming to be, you can see, more than 2. The pH is coming to be more than 2 here, students. So with it's coming around, this is 3, this is something more than that. So you can do the calculation and you will be able to get the pH. It may come to be around something like 2.87 or something. You can calculate it. What was the HCl pH 1? Because it's strong acid has less pH. This is a weak acid. The weak will have more pH than HCl. Okay, right or wrong? Tell me. So we can calculate the value of the pH. This is our pH starting here. Okay? And what is happening as you are adding base, what is happening here? Let us see the reaction. CH3COOH plus NaOH aqueous. What is the reaction? What will you get? CH3COO Na CH3CO Na plus what is you are getting? OH and H2. Okay? Right?
Yes.
Is the reaction. Now the story is that this, what type of salt is this? This is a salt of, this is a strong base and a weak acid. This undergoes hydrolysis. If it is hydrolyzed, what will happen? This Na plus does not, is a neutral. Na plus is neutral. It is only a spectator. It does nothing. I'm saying this is neutral because it is coming from a strong base. But CH3CO, what will happen? This will react with H2O. This will be hydrolyzed. This is not hydrolyzed. This will be hydrolyzed. You have studied in the hydrolysis chapter. What happened? This will form CH3COH and OH minus. Okay? Now, this ethanoic acid is a weak acid, but OH minus concentration will increase. If OH concentration increases, tell me the solution will be, what will happen to the solution? What will happen to the solution? When I add, I'm saying if this is 25 milliliter and this is 25 milliliter, what is the result? Both are 0.1. Okay? So if equal moles are present, what is going to happen? If equal moles are present, then this is the reaction which I have shown. Okay? Equal moles are present. This is the reaction which I showed. Yes or no? And what is the result of that? You are getting a salt which is made up of a conjugate base which undergoes hydrolysis to produce what? A higher concentration of OH at equivalence point. If the OH concentration is more at equivalence point, then what will be the pH? It will be less than 7, equal to 7, or more than 7. Tell me. At equivalence point, what will happen? You have larger amount of OH minus at the equivalence point. Why? Due to hydrolysis of the salt. The salt is coming from weak acid and strong base. It produces OH minus ions. What will happen? OH ions will increase the pH or decrease the pH? Tell me. What will OH ions do? Tell me. Increase the pH or decrease the pH? Base has been at, base is, it is basic. The pH should be above 7 or less than 7. Tell me then. What is the pH of a base? Less than 7 or more than 7?
More than 7.
More than 7. So here in this case, when you will do the titration of a weak acid with a strong base, you can see the equivalence point is coming at pH 8.73. This is greater than 7. pH is greater than 7. In the case of ethanoic acid base, you can see at the equivalence point, pH is equal to 8.7. Got it? You asked me this question in the first lecture. Will the pH be 7 every case? I said no. If the acid is weak, base is strong, the pH will be more than 7. How much it is coming? 8.73. Clear? Any doubt?
No, sir.
Okay, one more interesting thing. You can see that what is happening. Further, what is happening, students? See the situation. Here, you can see, in this case, what is happening? You have a weak acid. As you start adding acid, as you are adding strong base, in an acid, what is the result of that? What you are forming, you have acetic acid in the solution, and you have CH3COONA. Okay? This is a weak acid, and this is a conjugate base of a weak acid. Conjugate base. And such solutions are known as buffer solutions. So what they form? They form a buffer. Very important point. You know what is a buffer solution? You have studied this in 11th class. Buffer solution. What is a buffer solution? That solution which resists change in pH when you add small amounts of acids or bases. And the buffer effect is shown. I have shown a buffer zone. See the buffer zone? From here to here. So the pH will change less here in this region. Up to, you can see how much. This is 15, around 16 or 17, till 17 milliliter. You can see there is a less change in pH. Less change in pH. This is called the buffer zone because there is a buffer has been formed. And buffer resisting change in pH. But after you add excess, then buffer zone is over and then pH increases more. Here there is a less increase in pH, it increases more. And at 25 milliliter, when equal moles are there, the pH you can see is there's this much increasing, but this region is less than the region you have seen in strong acid. Strong acid, you have seen bigger region than this one. And strong acid and strong base, the pH was at 7, but here the equivalence point is coming at 8.73. Can you understand it? Do you understand what I said?
Yes, sir.
So the equivalence point pH has shifted to 8.73. More than 7. If base is strong and acid is weak. So we may look for an indicator which will change the pH from 6.5 to 10.8. 6.5 to 10.8. I may look for such an indicator here which changes its color during this range. So we have a list which we will see what type of indicators are used in such cases where you have a, even phenolphthalein can be used because it changes color around 8.72. So phenolphthalein may become from colorless to pink, or there is a thymol blue also. Thymol blue. We will see there is a list which can be used. So here the graph, this was the pH and this was the volume of NaOH. What acid I used? Weak acid. And there are two interesting things. For a weak acid, the equivalence point is higher than 7, which is around 8.73 here. And there's a buffer solution formation, which is called the buffer zone. So there is a difference between the titration curve of a strong acid, strong base, and weak acid, and a strong base. If we compare, What are the important points? First, for a strong acid, the initial pH is less. For a weak acid, the initial pH is slightly more. Then strong acid is completely ionized, weak acid is partially ionized. And initial part of the curve up to volume 24 is steeper because the weak acid is only partially ionized. For a strong acid, the curve is more steeper till 24 milliliter. But for weak acid, what you see, the initial part of the curve up to volume 24 centimeter added is steeper because the weak acid is only partially dissociated. The concentration of H ion solution is lower. If the concentration of H ions is lower, then what will happen to the pH? There will be, the more the change in H plus, the more is going to be the change in pH. So adding certain volume of NaH has greater relative effect on the pH than for a strong acid. What we are trying to say, in weak acid, you have less H ions. So if you add NaOH, then more OH ions are coming. If OH ion concentration is more, what will happen? What will happen to the pH? The pH will show more increase because OH ions are coming and H plus less H plus are in weak acid as compared to strong acid. Strong acid has more H plus, weak acid has less H plus.
Yes, sir. Less H plus.
Less H plus. So the effect of change of pH is more in this case. So the steep part of the curve is more in the alkaline region. The pH at the equivalence point is higher than 7, in the case of weak acid and strong base. So here, I hope you understood the complete of this. Okay? Further, what happens? Further, what is happening? Here I've made a comparison. You see the change in pH of a strong acid and a weak acid. You can see what is the difference between the two. What is the difference between the two? Let us see some more color. What is the difference? You see, this is my strong acid. The pH is less. Weak acid pH is more.
Yes, sir.
And strong acid has more H plus ions. So the change in pH is less, as you can see. But weak acid has got less H plus ions. And when you will add OH ions, this is steeper. This is steeper. You can see as compared to this is steeper. This part is steeper. And further pH at equivalence point for strong acid is how much? 7. And what is the pH at equivalence point for weak acid and strong base? Greater than 7. Okay? This is greater than 7. 8.73.
Yes, sir.
This was 7. So steep part more at alkaline pH, and at alkaline, as you add more OH ions because it is a weak acid is neutralized, so the steep part is more. And final pH approach is 13 because OH minus is in excess. What will happen? pH 13. Further important point that we can find the value determination of pKa from titration curve. This is important. How to determine pKa. What is pKa? You know, if Ka for weak acid. Acid is weak. For weak acid, we talk of Ka. We have defined it. What is the formula of Ka? What is the formula of Ka? We defined na CH3COH aqueous. Okay? What happened when it reacts with dissociated? We have given the value of this CH3COO minus aqueous and H plus aqueous. Okay? We have given the formula of Ka in the last page. How to calculate Ka? Got it? Here I have shown the formula. See the Ka. This is my Ka. ठीक है? This is a Ka formula. ठीक है? You have seen. So how will we determine pKa from the titration curve? From the titration curve. See what is happening. We have, what is our reaction? Reaction is CH3COH aqueous plus NaOH aqueous. It is producing what? This is producing CH3CONa plus H2O liquid. ठीक है? Reaction is correct?
Yes, sir.
This is expression. This is expression now. So what will be the expression? If I write the Ka, what is the Ka for this? This is a Na plus has nothing to do. This is actually CH3COO minus, because Na plus is a spectator ion. This is neutral. What is this? I can write it like this: CH3CO minus, CO minus, aqueous, and concentration of what is Ka, which we wrote for acetic acid. Acetic acid. What is the formula which we wrote? CH3CO minus H plus. ठीक है? So I can write it like this, divided by CH3COH. These are aqueous, all aqueous. This is aqueous. This is aqueous. This is aqueous. ठीक है? This is correct. How I write the Ka for acetic acid? ठीक है? Is this formula correct? Tell me. Any doubt? Is this formula correct or not? You tell me this. Is a weak acid? What is the Ka of a weak acid? ठीक है? Now, what I am doing, you had how much acetic acid you have taken? How much acetic acid you have taken? Tell me. 25 milliliter. How much acetic acid you have taken? 25 milliliter. And the result of this is this reaction. But you have taken 25 milliliter of this. Okay? And what you are adding in this NaOH? You are adding NaOH in 25 milliliter. In 25 milliliter. If I add 25 and 25 of this, then you have complete equivalence point. Tell me yes or no. ठीक है? But if you have 25 NaOH and if you add half of that, what is the half of 25? Tell me. 25 by 2. If you add 12.5, if you add 12.5 of NaOH, what will happen? 12.5 of this will go. How much will be left? 25 minus 12.5. Tell me. 12.25 plus 25 complete neutralization. If I add half, then what will happen? How much is this will be left? 25 minus 12.5 H plus. How much H plus will be left? Tell me. Half of this?
Yeah.
Half of this H plus. This is giving me H plus. This is giving me OH minus. So 12.5 of this will use 12, half of this H plus. And how much of this will be formed then? Because half is gone, then half of this will be formed. How much? This will be also 12.5. How much? Same will be formed here. So we will at this point when I am saying half is gone, when half at the half point of the titration, because the point in the titration when half of the amount of NaOH, when half amount NaOH has been added. Half NaOH has been added. Half of the amount of NaOH has been added. At that point, I can say that the concentration of acetic acid is equal to the concentration of CH3CO minus. CH3CO minus. Yes or no? Tell me. Half, half of this is going to form this. Half is now left. That means in this Ka, at this point, I can say that what I can say. Important thing, note down. This is equal to this. This cancels out. Then what is Ka? In this case, what is Ka left? Then Ka for this becomes equal to H plus H plus. Ka is equal to H plus at this point. Therefore, once Ka is equal to H plus at this point, what we are determining you at this point, where is 12.5 here? This is 10, this is 15. Okay? Let me see if I have a picture of that. Okay, here I have shown you. This is the titration curve of a strong base and weak acid. Okay? Starting from this is 2.3 or something, and this is the half of this. Let me see the color. Half this point, you can see 12.5 milliliter. 12.5 milliliter is half of the 25 milliliter. At this point, what is the formula you are getting? What you are getting? You are getting Ka is equal to H plus. Tell me what I derived. What is this? Ka is equal to H plus, correct? Here we have shown the same thing. Ka is equal to H plus at half the concentration of NaOH added. Then what is the result? If this is the value, then what will be the pKa? pKa, if I take the minus log of both, if I take the minus log of Ka, then I will also take the minus log of H plus. Okay? What is this? pKa, then pKa is equal to pH. So at half the equivalence point from the titration curve, I can read the pKa value, and that will be I can read the pH value, I can read the pH value, and this will be equal to pKa. pH is equal to pKa at half the equivalence point. Okay? Got it? So if I have made a curve,
yes,
this is 12.5, and at this point, what is the pH? You can say what is the pH here? This value. This is the pH. Here the pH is coming to be, if I will read this, 4.76. So the pH of this titration curve is 4.76, which is also the pKa of CH3COOH. Got it? So we can determine the pKa from the pH titration curve for a strong acid weak base by using half of the volume of NaOH. Got it? Understood?
yes, sir.
All right, then we are ending up this talk here. We will continue more about this in our next class. I hope you understood what I try to say to you. Good night. We'll see you.
Good night, sir. Thank you, sir.
Okay. मला